All right. Well, everyone, welcome to the August edition of the Astro Imaging Special Interest Group for the Tucson Amateur Astronomy Association. Um, I didn't see a lot of names of new folks on this evening, but if there's anybody out there who's a newbie, who this is your first meeting or you haven't introduced yourself before, please take a moment and introduce yourself to the group. Okay, I don't think there was anyone. And as usual, we spend the first few minutes dedicated to any folks who have what we would consider a beginner question. And Jeff will decide whether you're a beginner or not. So, are there any beginner questions before we get on with our main part of the program?
I have one, if I could be so bold, is in the USPS as we speak and to be delivered tonight. I bought a used Hyperstar version 3 for my C11. And I was just curious if you guys used any kind of a tool to calculate exposure times at f2. That's it.
Okay, you Hyperstar guys, jump in here.
No Hyperstar guys?
Yeah, I
Okay, well,
use
I'm on.
one. I use one, but I don't have
I
any
am a
special
Hyperstar
tool or
guy.
anything.
I just unmuted. Um, at F2, you're not going to need a real long exposure time. My experience has been, are you guiding with it? Or will you be guiding?
I can guide. I'd like to take short enough exposures where I didn't need to guide, but yeah, I
Okay.
have a guide set up.
Well, when I started out with my C8 and my Hyperstar version 4 and my 533 MC Pro camera, and it came with the AVX mount, it was all a package. I did not have a guide scope. I didn't get into guiding right away. So my exposures were limited to 30 seconds. So you can get, the nice thing about F2 is you can get a lot of data um, with a 30-second exposure. Um, Now, when you get into guiding, I found typically 120 seconds is typically what I'd be shooting at, sometimes 180. But you get a lot of data with 120 seconds. A lot of people just use 90 seconds. You don't have to do really long exposures because you're at f1.9 or f2. And what was your OTA again?
I have a C11.
Oh, it's C11, right? You're
Yeah.
also, yeah.
So I'm just worried about blowing out light areas, and that's why I don't want to
Yeah.
go too long.
Yeah, well,
When
if
you
you're doing like star clusters like M13 or you're doing galaxies, you definitely want to be cognizant of that. I've done, I think the first object I shot out of Starzone's parking lot when I first got the thing set up to work, I was shooting um, the Orion Nebula, and my exposures were like 10 or 15 seconds because of that central core that gets really blown out.
well, that's good because the Orion Nebula is coming up in the east now, and in a month
Yeah.
I'll probably have the opportunity to take an image of it.
Yep.
Thank you.
No problem.
All
Hey,
right.
Jim, I wanted to offer another perspective. I have a Hyperstar version 4 on a C11. And in fact, I'm about to, when I hang up from this meeting, I'm going to go down and once again try to work on the tilt with a photon cage. Um, but in my experience, because I've done a lot of work with the Deep Sky Collective, and they actually do allow, I have a one-shot color camera on there, and they do allow for one-shot color. We do a lot of work that's kind of primarily like narrowband or preferences mono cameras, but that's pretty tough with a Hyperstar. And if you may know about these collaborative results, these are hundreds and hundreds of hours of images. So you really want to get deep. And we did a bunch of experiments to try to see kind of what would be the ideal kind of exposure time and things for some of these. And I ended up doing a couple things that I didn't really expect. One is I'm imaging right now pretty regularly with 300 seconds on the Hyperstar. I find very little stuff blown out. I mean, the brightest stars, of course, are going to be slightly saturated, but really, the background benefits tremendously from that. The other thing is that I did is I set the gain to 0, which I don't normally do. Usually I use the high gain setting, but I really, really enjoy using it for dark nebula. It's almost like it's designed for dark nebula. Things that are just so faint, you can barely pull them out of the background. And I found with that combination of things, that 300 seconds, 0 gain, and I do run it guided primarily because the primary mirror is not locked down because I need to focus with it, of course. But I just found guiding really makes a difference for me. Those dark nebula just absolutely come out like nothing I've ever seen before. And those folks obviously who have Hyperstar, I think, can probably attest to that as well.
Well, that's encouraging. I had an image train off the back of the scope, and I was just about to buy a reducer from Starizona, and for about the same amount of money, I found a version 3 Hyperstar on cloudy nights, and I said, well, it's only $100 difference. I might as well just go all in and do the Hyperstar. So that's what we'll try. And stay tuned. Maybe the next meeting I'll have a result. But thank you. That's good advice.
Yeah, it is easily one of my most favorite things to shoot because within 2 or 3 nights, even with something that's like a dark nebula, you can just get some really great data out of it. And it's a lot of fun. I shoot stuff that takes months and months and months sometimes, and it's a different kind of fun, but I'm not sure I would call it fun. It's more kind of like a marathon, You're happy to get it done with, you're happy to finish it. It looks great, but boy, it is not that interesting when you're doing it.
All right, I'm going to let Jeff introduce our speaker, who we've already heard from, but I'll let Jeff introduce him, and we'll take it from there.
Great, thanks, Craig. So it's my pleasure to introduce Brian Valente as our guest tonight, and we'll conduct this as an interview, but I invite you all to use the little hand feature at the bottom of the Zoom screen. If you have a question about something that we're talking about, please join in. Brian is, I'll be brief, I could go on, but he's a tremendously accomplished imager. He's got 2 APODs to his credit. He is a member of the Deep Sky Collective, which if you follow AstroBin, every picture they post it winds up and IOTD. He is an industry resource, an expert on PhD2 and a contributor to the support group there. He's worked at Los Mandy. He now works at Astrophysics, deeply knowledgeable about NINA. So at the end of the session, if you've got questions about any topic in an area that Brian has worked in, feel free to pose it to him. To begin, we don't have a presentation here, but I do want to share a few photos just to set the scene a little bit. Everybody seeing screen? So here's one of Brian's APOD shots of Sushinchan Atlas from about a year ago. And here's one of the DSC shots, a great example of how deep they're able to reach with all those hundreds of hours of integration time. Speaking of dark nebulae, here's a recent shot of Brian's of the cosmic bat with the C11, Brian.
This is the CDK-20 down in Chile at Obstec.
Okay.
This particular one, I actually added another 20 hours of hydrogen alpha just to see what would happen. And the answer is not much, but at least it gives it sort of a nice glow to it.
Here's an unpublished shot of a wide field and deep field view of the Pleiades that hasn't made it out of Brian's staging area yet. but he allowed us to share it. And some shots from last year of Comet Pons Brooks with the remarkable changing tail.
Yeah, spectacular comet. Yeah.
So with that, as an introduction, Brian, tell us a little bit about yourself, where this passion for astronomy came from, and how you became a professional amateur astronomer.
Sure. Well, thanks for that introduction, Jeff. I never thought of myself as a professional amateur, but I spent a bunch of time in startups in Silicon Valley in my early days out of college, and this is back, I think, when Silicon Valley was a little bit different than it is now. But I would join companies, 3-4 people, and then we'd build it up and sell it off, or it would be acquired or something, hopefully at some point. One of the companies I did kind of invented and popularized the notion of receiving your bills through the internet and then paying them, which at the time, way back, probably in the late 90s, no one thought was possible because commerce on the internet didn't exist. So, you have me to thank for that. I don't know if that's a good thing or a bad thing, but we can do that pretty regularly today. But I moved on, and I spent about another 10 or 15 years in Hollywood with doing kind of similar sort of hardware, but instead of astronomy, it was for independent film production. So we made all sorts of equipment to allow small producers to produce videos and productions and films that looked as good as the big studios, which back in the time was kind of the model. And at that time, I got involved in nature and landscape photography, and really enjoyed it, I think, as we all kind of do. And at that point, I really ended up running out of time. Things got really busy. I was on set a lot of the time, and I thought, well, this astronomy thing I've heard about, it sounds like I can take the enjoyment I have of taking pictures, and there's a bit of creativity and a bit of technical expertise. I can just set something up in my driveway and sort of enjoy the same experience. And unfortunately, this is deep urban Los Angeles. If there is such a thing as a Bortle 10, I mean, it's going to certainly qualify as one of them. I mean, I think we saw maybe Sirius and maybe sometimes Orion's Belt, and that was about it. So at the time, and this was 2010, this is just the end of kind of manual guiding, where you had to go out every night and press the buttons and kind of keep the guide star in there in the field of view. And it was basically a horrible experience. And in fact, I put it away for a couple years and was almost going to just sideline it. And then at some point, I just got a pole master, and I seemed to solve like a ton of problems that I had, and just fell in love again with the idea and with the effort. And then so I started kind of imaging somewhat seriously, and it's like, I think a lot of us, I have a real interest in problem solving to the point of probably damaging myself. And if there's some creative aspects to it, I really enjoy it, but there's also certainly some mechanical or technical aspects even better. And somewhere around, I would say probably 2015, maybe a couple years in there, I bought a Lost Mandy G11, which is kind of a love-hate relationship. But I could never, ever get the periodic error to work. The periodic error correction just could not get it to. I didn't understand it, didn't know why. But I just decided that was the hill I was going to die on, and kind of bumped into Ray Graylack, who's the author, and we sort of worked on it a bit. And then I eventually talked to Scott and Tanya over at Lost Mandy, and was talking about it. And it's pretty clear that Scott's a very dedicated guy. Scott Lost Mandy, by the way, the owner and the primary architect of Lost Mandy products. It was pretty clear that they were very passionate about building this stuff, but really we're not imagers. When you become an imager, you really appreciate all of the nuances and issues and just trying to get it right. That is very different than, I think, just making these products. So I got involved with them. They asked me to test some things. I was happy to do that. I tried to answer questions on the forums. and really just help. One of sort of my themes about how I got involved in this is the best way to learn something is to try to teach other people to do it. And you just find it's a completely different experience because it's not just teaching what you know, it's trying to understand their problem and their equipment and how they choose to use things that might be different. That is very, very different and very difficult, frankly. So I got involved with Lost Mandy. They eventually hired me on to be their primary technical support person, which I was happy to do for a number of years. Also got involved with the PhD folks in a very similar sort of way. Just decided I was going to try to understand guidance better than anybody else, and what better way than to just start volunteering on the forums. And I think for the first year, I answered questions and misled people terribly for a good 12 months. I just gave the worst possible advice. Bruce Waddington, who's the author right now, constantly correcting me, but eventually I got better and started to understand it. And I would ask him a lot of questions offline. And now I'm Bruce and I are the kind of the main people that answer questions on the PhD forums. We've got a new version coming out. There's nothing terribly interesting about it, but it continues to evolve and be a better product. And for those of you folks that have mounts with absolute encoders, that was something that Bruce and I worked on, but I kind of approached him and said, we need some additional features for encoder mounts. This sort of delaying feature isn't really working. It takes forever to settle, it takes forever to calibrate. And so we added in the variable exposure delay features and some other things. And, now I've become one of the three people to help support PhD. That's Bruce Waddington, the primary software author, and Andy Galasso, who's behind the scenes doing a tremendous amount of work, but we just don't really see him that much. And I just try to play my part in all that. So after a bit, I decided I was going to move out of Los Angeles. Lost Mandy was based in Burbank, so distance-wise, that didn't really work out too well. And I somehow bumped into astrophysics. I think Ray was suggesting that I try to do some work for them and some videos and things like that. And kind of one thing led to another. And I think next month it will be 2 years that full-time I've been with astrophysics. One of their primary support people. I do have a lot of astrophysics equipment here, so of course I use it. And I have a 1600 down in Chile, and we have two of them down there, which I think we'll talk about here momentarily.
We will.
But we have just a lot of equipment, and I'm just my goal is to learn to run it and to make as many possible mistakes as I can before anybody else, so that when people run into these problems, I will have gone through that and can help understand and explain to them what we can do to make that work.
I'm glad you have made so many mistakes, Brian, because I think I'm only one or two mistakes behind you, but every time I make a mistake, you have been there to straighten me out.
I have made that mistake, yes, and I appreciate that. So
thank you for that. So it's been a fascinating journey, but it sounds like you have a real passion for education and helping others.
That's fair, but I want to be honest. Like, my goal is to be the best imager I can be, and the only way to do that is by sharing and giving away and helping others. So I want to make it sound like I don't want to make it sound like it's more magnanimous than it may be, and I really do enjoy it. I mean, I meet fantastic people. There are so many smart people doing so many incredible things. And, one of the things I've realized is there's just no way for me to know everything, but I'm going to do my best to contribute as best I can for the things I do know, and try to know as much as I possibly can.
So can you share any tidbits? Scott Lost-Mandy, Roland Kristen are, leaders in this field. Tell us what they're like personally.
Well, Scott is an interesting so Lost-Mandy is a relatively small shop. I don't know if anybody owns Lost-Mandy gear or has owned it in the past. It seems like everybody in the U.S. has owned a Lost-Mandy at one point or another. They are extraordinarily well-built machines that seem to last forever and ever and ever. Scott personally, he comes in and his job is basically to take that last 5% where everything kind of comes together and he tunes the performance of the mount, and that's kind of what he focuses on. The rest of it is a machine now. They've got a number of people in the back, they're machining parts, everything is made in the US. Renee, who is the guy that wrote the Gemini software, he and I worked quite a bit. And in fact, level 6 Gemini firmware was kind of my baby. That actually was the eventual result of how we got PEC working in the Gemini. And right now it actually works fantastically well. If anyone has a Gemini, level 6 is where it's at. It's a great piece of firmware. And I think it's finally realized what these mounts are capable of. But Scott is sort of a curious guy. He really enjoys machinery. He enjoys like kind of vintage machines, anything that's mechanical. He's not a fan of necessarily electronic stuff, certainly not computer stuff, but he has got an enormous collection of vintage mechanical devices. These are anywhere from really, really old arcade machines. He's got old armor. He's got like some medieval armor suit that he has in his house. And he really is very, very passionate about those things. And he loves to drink. So he is a really nice guy and very gregarious. He just sort of likes to stay behind the scenes and kind of do his part. Roland, Kristen, on the other hand, I mean, I don't know if a lot of people know this, but Roland is absolutely brilliant and has been doing this for forever and ever and ever. He is a bit more of kind of a genius. He's the mystery guy behind the screen. I work with him on a regular basis, but I don't necessarily work direct with him. So I'm personally in Oregon, and everybody else is in Illinois, in McChesney Park. And Roland has an observatory out there. And any clear night, Roland is out there testing things. And this is it's not an automated observatory. So he's got to physically move the roof back, and he's got a couple of piers in there. And, right now we're testing, he's using the 155 that we announced, the Christian Super Acromat, and the 190, and a few other things that are can't talk about. But it's funny because I know the skies are clear because Roland starts sending me all these emails about things. And we just kind of have this chatty conversation about targets or about, how things are performing or what do we think people want in the world. And, Roland knows so much that a lot of times I find myself just sort of talking to him about topics like how to judge a refractor, and look at how to read the charts and why are the charts not all the same from different manufacturers. But he's a really brilliant guy, and but he's just not. We don't really ever talk in person, partly because of the differences. But I think Roland prefers to speak via email because it allows him to sort of organize and collect his thoughts. So he's suffering a bit in Illinois because of there's very poor sky conditions. It's very, very bright. And there is around astrophysics a company that I'm not sure what they do, but it involves large stockyards of things with very, very, very bright lights. I mean, I'm talking industrial style lights. And they're apparently buying up the land around astrophysics. And so he's bemoaning not being able to shoot, only being able to shoot in narrowband. I keep suggesting these targets, and he gets mad because some of the targets, like we were just talking about Able 78, he says, I don't have 30 hours to shoot these things. I have like 3 hours tonight, and that's it. So sometimes we collaborate. I don't know if we are going to show the M63, but I did publish one of the extended tidal tales of M63, and he got out there in Hawaii and was able to image some luminance for me. We were talking about luminance earlier, and be able to contribute that. And so sometimes we do these collaborative efforts. We also shoot with the 12-inch MacCast that's astrophysics down at Las Campanas. We're very fortunate to have that set up. But a lot of times I will run the telescopes down there. So he's not a remote guy. He's a very, very much an in situ, like He wants his hands on the telescope. He wants to be running it. He wants to see what's going on, because his criteria for success in using a telescope is much different than ours, right? He's not about deep integration times and gathering a lot of data. He actually wants to put his hands on the telescope to watch what's going on, to change things, and to see how this thing is going to perform. So many times he'll suggest targets. I'll get involved with the data acquisition and imaging, the basic kind of processing, and then he will either finish up the processing or we'll do it collaboratively, and then we'll produce a number of images that, Jeff, you've probably seen we do on the astrophysics group. We used to do a little bit more before our roof down there had to be repaired.
And I would encourage everybody to take a look at Brian's AstroBin page. I believe the M63 picture is there. It's a great target, but I mean, your image, Brian, gave it a spherical, three-dimensional quality that I found really striking.
Yeah, it was about 80 hours of luminance, I want to say. So 60, 70, 80, somewhere in there. And you just realize that the new frontier seems to be these very, very deep integration times that either are finding these narrow band structures that we didn't know exist before, these planetary nebulae we didn't know about. There's another Able 36, which is one that I've been working on now and been gathering almost 100 hours of O3 data. And there's another shell that exists outside of it that I haven't yet seen. But boy, you talk about trying to gather that much data, and the only way to really do that is either through a combination of telescopes or totally automated imaging. So I think we all saw probably the Astro Imaging channel recently. A couple of weeks ago, there was a session on completely autonomous imaging, and that's one of the things I have down there in Chile is the target schedule running 24/7.
So you mentioned these very, very deep pictures. The thing that I find so interesting about the Deep Sky Collective is that they're filling a research niche that the professionals really can't do, because you can't get that kind of time on the big telescopes.
Yeah, so I had a very interesting discussion with a guy named John Hoot. He's one of the fellows. He's an old SBIG guy, I think. But he's one of the people who contributes to the Las Campanas Remote Observatory, the setup that we have. And maybe, I don't know, Jeff, maybe you can sort of skip to that. I think we have a slide that sort of shows that, or maybe a couple slides on that. And that might be down in sort of 13 or so, somewhere in there. Yeah, so this is
much as you, Brian, would love to own these telescopes. These are not his telescopes.
No, they're not. But these are the Twin Magellans. But down the road, so in looking at this picture, if you go back up the road, or if you were to turn around, you would see the Twin Magellans on the peak behind us. In the distance on this one is the DuPont telescope that does the sky survey. And then there's sort of a smattering of these scopes right in front of this that you don't see, but there's a building to the left. But if you were to sort of back up a little bit more, is the Swope telescope. And there's these sort of smattering of other telescopes. And right where I'm pointing is LCRO, which is the official sort of name of the astrophysics installation there. And that's a nice roll-off roof. I think if we have the next picture, it sort of shows what it looks like. There's actually two telescopes in there. This is the one that we run with the 1600, an Astrophysics 1600 with absolute encoders. It's a 12-inch MAC-CAS. I believe the image scale is about somewhere around 0.4 or so. It's an extraordinarily sharp telescope that I can match very easily with the 20-inch CDK because it has a much smaller obstruction. And so, these optics are beautiful. Roland went down there and personally hand-tuned it. We don't have the Proline, the 16803 camera down there anymore. I think we have a ASI 6200. We do a lot of science and imaging, just sort of artistic imaging. We ran into a problem that in order to do this, we needed something like 20 filters to run this. And the problem is that kind of filter wheel doesn't really exist. And so John, we took the Proline filter wheel and filled it full of filters, and then had one blank one. And then we took a ZWO filter wheel, I think, and filled them all full of filters and had one open. And he wrote a kind of a custom ASCOM filter wheel that somehow, I don't know exactly how it works, but, basically whatever filter you want of these 20, whether it's the Sloan's or the, just standard LRGB or narrowband or GRISM or whatever, you can get access to that. But the reason I mention this is because, John, we were talking about the Vera C. Rubin telescope. And we are in the process, I use Nina when I am down there. And we have a setup where anytime we're imaging, we being astrophysics, we use that. He's an ACP guy, right? Which is Bob Denny's. And, he has recently mentioned that he is no longer going to be supporting this and shutting it down in about a year. So all the people on ACP, including John Hoot, are thinking about moving over to Nina. And he does a lot of science work. And we were sort of just talking about what it would be like to run Nina and whether you could do outreach on Nina, things like that. And I was mentioning that there's this target scheduler that allows you to set up targets and then they run automatically. And one of the features that Target Scheduler has that they're thinking about in the future is the ability that as it's going along and automating these processes, that if there was an event like a supernova and you were subscribed to a certain network of data, that it could take that information about the supernova, stop whatever you're doing, move the telescope over, be able to image it according to whatever. And I said, and I was very proud of myself. I'm like, hey, I know all about this, and it's a really interesting thing that's going to happen. Now, I personally don't shoot those kinds of things, but I can see if you're into that, that'd be fantastic. And he said, I just came from a meeting. This was last week I was talking to him. He said, I just came from a meeting where the Vera C. Rubin, the number of events like that they anticipate are going to be on the order of 5 to 10 million per night. This is an extraordinary telescope that's going to be able to find these things. And the problem that they're dealing with right now is there's just no way for anybody to subscribe. There's just no way you could subscribe to that many. And so their work that they're doing right now is trying to set up these brokers and notification services so that you could subscribe to only the certain things maybe that you're interested in, because the amount of discovery and follow-up, and this is really where I think amateur science imaging is going to have a heyday, is going to be absolutely transformed by this telescope, it is going to come through this work that they're doing to try to make it more available so that we can point out these events and have people subscribe to them and be able then to image them.
Well, that is fascinating, and I want to return to what you see in the future of the hobby. But while we're looking at the LRCO scope, you had a pretty significant role in setting this up. Tell us about that, please.
Yeah, so I prior to this, I think in 2019, my imaging partner at the time, Greg Stein, we decided that we were going to go remote. And at that time, we really decided we were going to go all in on Chile. And at the time, it was OBSTEC, which is really at the time, I think it was pretty much the only option we had available. Las Campanas is not so just to be clear, Las Campanas is kind of like Mount Wilson, right? It's a scientific consortium. You cannot get a telescope and go there and say, I would like to host it there. So we kind of lucked into having this available, and I'll talk about that in a moment. But at OBSTEC, we needed to commission and remotely set up a telescope and a whole system, which we had absolutely no experience with. And I think you're going to back up, and we'll show that in a second. So that's, if you can tell in the back left, the tallest telescope there, yeah, that's my telescope. By the way, the one in the front, on the front left, that's kind of pointing up to the right, the reason I asked about, we were talking earlier, that telescope is partially run by David Churchill, and there's a you can't tell, but I think it's a CDK 17 and a 130 EDF they have on there, and they use it pretty regularly. So that might have been a source of the data. Martin Pugh is in the back there with his CDK17 on his Paramount. But this was at the time of COVID. And so just as we were about to launch this thing, everything got locked down. So we couldn't go down there ourselves. We had to sort of figure everything out remotely. At the time, PlaneWave, when they shipped our original CDK17 that we upgraded to the 20, they neglected to assemble it correctly, and they were missing pieces, like the primary baffle was missing, which resulted in some really pretty wild images. And we had to really struggle to solve all these problems remotely and work with those folks because we weren't there. We couldn't figure out what's going on. The only view we had was of this observatory camera. So eventually we got it working. And one of my first kind of major introductions to astrophysics and their support was that the encoders on our 1600 in OBSTEC, this one, was slipping. We didn't know that at the time. We just said, I don't know, it doesn't seem like it's tracking very well. So they eventually fixed that. So when Las Campanas came back up, I think about 2023, we were looking at recommissioning it. It had been down for a little bit and kind of been underused, and we decided to move to the ZWO camera from the 16803. We wanted to kind of redo everything, and they put me in charge of the astrophysics side of things. So we got a little B-Link computer. We have a little B-Link. You know, B-Link are the little mini computers. You know, the little NUCs. I think everyone is familiar with. But we got those up and running, and we had to load all the software and test it. And I'll tell just a brief story. So Roland went down there. So this is Roland Christen. This is my first experience. I'm very, very nervous working with him. He doesn't know me from a hole in the ground. I'm just some guy who started working at astrophysics. And he and Marge were down there. And so they were working on the scope, getting it commissioned, cleaning it up. He was adjusting the optics, doing the back focus and everything. And he was down there for about 3 or 4 days. And he says, okay, now it's your turn. Everything's ready to go. You need to build a model, a sky model for accurate tracking using APCC, which is our software to do this. And I'm like, great. I'm looking forward to really, showing him what I can do. And so the first night, I ran the telescope into the pier so badly that I couldn't unlodge it. Like the telescope wouldn't move. And I was horrified about this. And I had to say, listen, guys, I'm so sorry. You got to go back to the telescope. You got to sort of fix this thing. And I won't get into the details, but it wasn't my fault, turns out. But it was just a horrifying experience to do this. And eventually we did, get it fully set up. And all of the mechanisms that we needed for safety were now in place. We got the horizon limits, the meridian limits, all the encoder limits so that we can avoid having any of those sorts of problems. And I came to appreciate what it would take in software and other types of features to make sure that things like that don't happen. Because once this is up and running and we all leave, the guys in Las Campanas are really focused on the Magellan telescopes, the DuPont maybe, but they, we're way down the list in terms of support. So if we screw something up, it's going to be months before, or weeks, I should say, but possibly months, depending on what it is, to really go and fix it. So we have to be very, very thoughtful about the kinds of safety mechanisms and other remote observing capabilities that we have in there to make it work.
Well, Brian, let's travel back north and talk about your backyard.
Okay.
Because in addition to, well, you've talked a little bit about the OBSTEC scope, and you've mentioned, but maybe you want to unpack this a little bit more. So it's running Nina. You've now got the planners set up so that it's an autonomous machine now, right?
Yeah. So originally when we started, my imaging partner, who's not as sophisticated as I am, in terms of, well, I should probably say, he just doesn't have the time to learn all this stuff. You know, when you get involved in NINA and things like this, you really have to spend time on this. And he's more of a kind of a casual observer. So we started with Sequence Generator Pro when we were doing imaging in Los Angeles. And then when we moved it down there, we kind of stuck with Sequence Generator Pro. And eventually we moved over to NINA because we wanted to automate other things. We wanted to automate the collection of flats. We wanted to have certain types of actions happening if the safety monitor, which they have there, goes off. Just a lot more flexibility that we were looking for. And so eventually, the challenge sometimes with having a remote system is that even though it works, it may sometimes the connectivity or the communication doesn't work as well. So as you might expect, there's many people in the United States who are down there, and that come around dusk, everybody's logged in and trying to do stuff, and sometimes you may not be able to get to your computer. And it's a real thing, you know, or it goes so slow, and then you're pressing a button expecting to be able to do the next thing, and then suddenly, you know, the VPN cuts out. So I really felt like the best way to take advantage of something like this, once it's up and running and performing well, is to use the target scheduler, which I'm assuming everybody knows what that is, but that is the fully automated. You don't really set up a custom sequence, or I guess more specifically, you set up one custom sequence with a container that just says, target scheduler, do your thing. And then in the plugin, you define all of your various exposure times, you know, your plans for that, and then the various targets that you want. And it will figure out for a given night what it's going to image, how long it's going to image for. It changes the scopes or changes the targets. And I use pushover, so I'm informed. I mean, I'm kept abreast of what it's doing. I'm starting up, I've cooled the camera, you know, I'm imaging this target now, then I'm going to move to the next target. Okay, I'm all done for tonight. One of the things, it's a good example of what NINA does that I like, is that I had this problem where I kept logging in early to sort of add some more things to the target scheduler. And for some reason, the Moravian camera we have, it's a C5, so it's the big, you know, medium format chip. The cooler was always on. It wasn't much, but it's always on like 8%, 9%, 13%, kind of randomly. Like, what is the deal with this camera? So I put in some instructions for telling me like what the camera temperature is during the day. And what I found out was that when you ask it to warm the camera, it warms it to ambient, but the cooler is always on. So of course I would warm it at the end of the night in the early morning when it was somewhat cool, and then it would heat up during the day and the cooler would kick in. So I realized, oh, I see. I talked to the Moravian folks, are like, yeah, it works that way. You got to turn off the camera. So now I have, in addition to other things, the data logger switch that I can automate in NINA and just put in some instructions about turning off the camera at the end of the night, and then the start of the session turns on the camera. And I add some pushovers, notifications in there. It tells me, hey, you know, camera's turned on, camera's cooled to a certain degree, so I know that it's working.
Interesting. Thank you. All right, so let's go back to your backyard now. And
yeah, so I moved
to. I'll flip the view at the appropriate time.
Okay, so in 2022, 23, somewhere in there, I moved to Oregon, to rural Oregon. My real goal was to get a place that was healthy living and enough land that we have these big dogs, these Irish wolfhounds. They like to run around. We had just experienced in Sacramento area, I think, a week's worth of over 110 degrees Fahrenheit. And we're just like, we can't do this. We can't live through this. So it just happened to be.
Remember who you're talking to here.
Yeah, no, I understand, but we just couldn't. In California, we're not set up to handle heat like that, right? No, like we didn't have an air conditioner that was designed to run like kind of all the time. So, you know, decided to move to Oregon, and it just is a nice kind of just serendipitous thing. We moved to an area that's just right outside of the Umpqua National Forest. It's got, I think, Bortle 2 skies. Our seeing is kind of not great. It's somewhere between 1.5 and maybe 2.5 arc seconds in the winter when it's bad. But summer right now, it's about 1.5. So it's, beautiful skies, very dark. And I just had started working for astrophysics, and I said, I really need in addition to doing my own imaging, I really need to have a laboratory for testing and failing as much as I possibly can. And I needed to set it up in a way because many of our customers and many people do things remotely and possibly fully autonomously. But I needed to have something set up where my rule was I can't go down and do something. I have to do everything that I need to do remotely. So I designed this myself. It's a 10 by 20 observatory. Had some guys come in and build it. It has 3 piers in it. These are skyshed piers. I've got, I don't know, maybe 5 or 7 telescopes in there that I switch out. The picture here, which I think was a somewhat earlier picture, this is a C14 that was designed for planetary. And I've since found out that in the winter, our skies are so bad that I just gave up on planetary. It was just absolutely terrible. But that's a G11T there. I have a Mach 2 with a 130 EDF we were talking about earlier. So that's my main astrophysics telescope. In the back is a Mach 1 with the C11 Hyperstar. And then there's a 10-inch imaging newt. I think I have a 10-inch RC, a 12-inch RC. Behind you can't really see it, but behind the Mach 2, there's another tripod that sits back there. And I just kind of jammed it over there and put a little ASCAR, I think it's an FRA 300. Yeah, that little guy right there. Just put it on a little G11 and just said, shoot the Pleiades as much as you possibly can. And that's where that deep field Pleiades came from. And it's just nice to have the ability to be able to set these things up, not really worry about whether sky conditions are changing. Even the roof will. Now, the interesting thing here is that all these are pretty tall. So I have to park them in a certain position in order to close the roof. And I have sawed off plenty of telescopes in trying to get this working until a point now where we've got a safety monitor. I use the Sky Alert and Sky Alert and Sky Roof from the Interactive Astronomy guys who are based out of Chico that controls the roof. The safety monitor will say it's unsafe. Everything parks. The roof closes. We're in good shape. So this is kind of where I do all my failing and hopefully some good imaging. As I said, it's really, my goal is to do as much as I possibly can on all these different telescopes and focal lengths so that I can really understand best how to advise people on whatever it is that they're doing.
Well, thank you for that. For me, it helps me understand a little bit where the extraordinary breadth of your knowledge has come from. I want to save some time for questions, but before we go to general questions, you had a few thoughts. You've spent some time thinking about the future of this hobby and of accelerated learning and development. Look into your crystal ball and tell us what you see.
Well, so in astrophysics, we typically work with a lot of folks who have a lot of time. Fair bit of money, but a lot of time because they really, they're trying to buy the best and they're trying to do the best with these things. We are absolutely seeing remote observing, particularly in the United States and West Texas now that Starfront has kind of democratized the costs and complexity of that. We are seeing an increasing amount of interest in. It used to be deep field. It used to be like, the bigger the scope, the better. The longer the focal length, the better. And nowadays, it seems to be that the new frontier is all about deep integration times. So faster optics, we talked about the Hyperstar, which is a great example, but there's a lot of different things in the F3, F4 range They're becoming extremely popular, multiple telescope setups. So one of the things that I'm actually in the process of, I mentioned I decommissioned the C14. I have another 120 telescope that I'm going to put in tandem with the other 130 there. The 120 is going to shoot the RGB, and the 130 is going to shoot. So they're going to be in tandem together, and they're going to shoot a combination of narrowband and broadband. And the goal is to accelerate the amount of data that I can collect at any given time. And that seems to be a very, very common theme that's coming up. But one of the things that I'm really seeing a lot of, and Jeff, I know what you were kind of alluding to because we discussed this, but I'm very, very surprised at the role of AI in not just the types of things that we are probably used to. I'm sure everyone probably uses Russ Krollman's plugins, which are, again, an expression of AI and machine learning. He kind of modeled all of the polynomials that involved in optical aberrations and things, and then he just built this incredible tool, Blur Exterminator, and some other things that really, I think, have changed. Have really defined, I think, modern processing in many ways. But there's a number of things that are happening, in particular around vibe coding, which I don't. People are familiar with that, but the notion that you can type prompts into ChatGPT or whatever AI you're using, and it will actually produce software that's meaningful. I have seen in the last even 2 years, things change absolutely radically, such that the kind of software that I think that we're going to have access to as a relatively niche market is going to explode. So I didn't share this with you, this specific example, Jeff, but a couple nights ago, I ran into a situation where what I needed was an ASCOM client piece of software that I could connect to do some testing and to send commands directly to the telescope. And there's a long list of reasons why the normal software I had didn't work. And it was a serial connection, and couldn't get it to work. So I went to ChatGPT 5 now, which is the new one that people are kind of complaining about and panning it. But it turns out for the kinds of things that I'm talking about is actually an extraordinary step forward. So I figured I'll give it a try. I've done some tools in the past that have, with this vibe coding notion where I just say, can you build this in Python and give me a kind of user interface? And I want to look at it this way. And I just said, hey, listen, can you build me a software that will connect to a mount via Alpaca, which is an ASCOM kind of standard? I just vaguely notioned that. And I need to do the following things. I need to be able to connect to the mount. I need to be able to handle any errors that are happening. I need to know what the mount is I'm connected to. I need to do basic functions like park, start tracking, stop tracking. And I need to be able to send commands to it directly. Can you do it? And I was expecting in the past in some of these AI tools, and in ChatGPT 4.0, even just the one prior, it would say, yes, I think I could do it. And, what would you like? And, I can do it in Python and things. But instead, it actually produced an application. Like it just sort of sat there and thought for a bit. And 35 seconds later, it said, try this. And I opened it up, and this user interface, it was extraordinary to me. Should I show this real quick? I don't want to make a demo of it, but
by all means, I'll stop sharing, and you can.
I don't want to. It's actually request has been sent. So let me just see if this is going to work. Now I don't want to suggest this is any sort of magical interface, right? This is not a great thing, but this is what it produced, right? It recognized that there was a host name, there's devices, I can query the devices. This is actually the mount that is down in the observatory. And the latest versions of Nina have the ability to expose everything that they've connected as an Alpaca device. So I can connect to it, I can disconnect to it. Now, one of the things I wanted to do was be able to load sky models, and so I, put a model folder in and lists all the modeling files that I could send. But I can, do right ascension and declination or hour angle. I can have it slew. I can have it. I didn't even know it was going to do the async slew, which is a new thing in Alpaca. Set all the tracking rates. And, here's my sort of list of commands that I have. There are custom commands. I can click on it and it tells me what it is. And then, it'll actually show me if I connect, I think. So it'll show me where this mount is pointing. Now, again, I'm not suggesting this is some miracle of insight in terms of what it's looking at, but this took me 30 seconds to write, and it produced this application, and it works, right? So I don't want to. The roof is closed right now, so I don't want to, bang the scope into the roof again. But I just wanted to demonstrate like the kind of thing that I'm seeing coming out of AI and vibe coding is extraordinary. And it really, when I showed this to our guys, Mike Hansen, who is our kind of a lead developer, he's got a background in aerospace, and he works on the control box and all the magical things that happen there. Very, very complicated stuff. We couldn't figure out how this could have happened. He just said, it would take him months to produce something like that without these types of tools. So I'm very, very excited. I don't think it's going to cause software developers to lose their jobs by any stretch. But in terms of getting something basically working or getting functionality that kind of is on the periphery, maybe it's not critical, but it's nice to have. I think about plugins, things like that, maybe. I think it's really going to make a huge difference for us coming. And I think it's kind of coming now.
Fabulous. Well, Brian, thank you so much for this. I'd love to take, we're getting close to our time here. I think we might be allowed to go a couple of minutes over, but questions from all of you, general questions about PhD 2, your G11, APCC, Nina, Pix Insight. We didn't even talk much about PI. But, if you have a question, throw it at Brian.
I have one. Brian, thanks. We've talked a couple times on the AP forum, and you've helped me out, so thank you for that.
Great.
Could you comment or give some ideas about the topic of doing unguided imaging with an encoder mount, something like the Mach 2?
Mm-hmm.
What some of the most important elements are of doing that accurately, especially with optics in the range of 1500 to 2400 millimeter focal length? What are the key elements of doing that? Obviously, maybe using APPM and so forth is important, but are there other subtle considerations that you should keep in mind when you're trying to do that?
Sure. And you're talking as a general topic with some astrophysics kind of specifics in there?
Yeah, specifically, I guess you could say with astrophysics encoder mounts. Is it
Okay.
is it something that you would just, do a sky model with APPM? Seems to work fine. Everything comes out pretty well, but you're not always sure whether or not the setup is exactly correct. I mean, mechanical aspects of the telescope, the mount, polar alignment, things of that nature. What are the most important elements of being able to do long focal length unguided imaging?
Sure. Great question. So let me start by giving you an example of how I managed to fail continuously at this for a long period of time. I had mentioned about the CDK in Obstec down in Chile. And our goal, we were convinced coming out of AIC, the West Coast AIC in 2019, that we were going to be the guys to break the code on doing unguided imaging for, this type of setup. We're going to buy this mount. It's got absolute coders. We looked at this APPM, this sky modeling software. We're going to make it happen. We're going to build the most dense model. We're going to do, have the best possible environmental sensors. We're just going to pull out all the stops. And After working on that for about a year, almost a continuous year, every night working on it, the answer that I came up with for that particular setup was you can kind of do it, but it really, there are so many variables. So let's talk about what is required. So first of all, and there's a video we have on our YouTube channel that kind of talks through the components. So first of all, you need to have a mount that tracks very accurately and doesn't have periodic error. Now, it could happen to be that you have a good mechanical specimen and you've done a great periodic error correction, but almost always you're going to need some sort of absolute encoder. The encoders are like just this instantaneous micro, nanomillimeter type of watcher that it kind of go as the encoders move along, it'll know if it's going too fast or too slow, and will always bring that back so that it basically eliminates periodic error. So encoder mounts absolutely central to that. The second thing is when we talk about things like telescope flexure, we talk about things like polar misalignment. These are things that are going to exist in an encoder mount it's going to exist in any mount regardless. So in order to resolve those issues, you need some way to model them and compensate for them. If you have slight polar misalignment, and by the way, polar alignment is not an event, it's a process, right? So oftentimes in these remote systems, polar alignment changes, right? Things settle, the seasons change, your telescope, the flex kinds of moves some of the screws, who knows what it is. But in my direct experience, polar alignment can change. Now, not much, but it absolutely changes. And the question is, what do you do about that? Do you call them up and have some guy go down there and try to repolar align it? Or you can use sky modeling, which actually will compensate for polar misalignment as one of the many things that it does compensate for. So redoing having a sky model and doing it on a fairly regular basis, I would say every 3 to 4 months, makes a big, big difference. The last thing, and this is the part that's kind of the most tricky, is that the system you have, and by system, I mean not just the mount, everything, the mount, the telescope, the way that it's mounted, the types of environments that you have around you, whether the ground shifts or dries out or swells during different seasons, those all affect the accuracy of the mount pointing as it moves through the sky. And so anything that's repeatable, the sky modeling can, as long as you can do it over and over and over, and it has the same result, you can model that out and you can use unguided imaging. However, and a great example is we were talking earlier about the hyperstar. A hyperstar and SCTs with an unlocked primary have a lot of variability to them. It's not that it's bad. I mean, I love SCTs and I got a couple of them, but by their nature, they have a lot of things that happen in the telescope that are not the same from time to time. And as a result, sometimes we have a process we use in APPM. It's called the 5x verify. And if you're thinking about going down this route of unguided and these sort of longer focal lengths, I encourage you to use this tool. You build a sky model of, say, 30 or 40 points. The goal is not a dense model. It's just a kind of a comprehensive points across the sky that will have the telescope pointing at all these different locations so that we can test how the telescope flexes or moves. And it just repeats that 5 times because what we're looking for is consistency. And in fact, I might give you can I show this to you? I hope I can. But it might take me a moment to find this. But if we can see the 5x verify, we can measure with some degree of certainty how much of the differences in pointing accuracy are repeatable and how much are so variable that you're not going to get the same result from night to night. And this is particularly true as you start to point in places where the telescope is really, pointing towards the horizon, pointing maybe in the opposite direction of Park 3, so it's maybe pointing in the southern hemisphere for us up here, or northern hemisphere if you're down in the south. And in environmental conditions also play a big role as well. So having an accurate sensor at the point of your telescope is important because temperature and pressure affect refraction, and refraction can be a pretty significant difference in terms of the tracking accuracy when you start doing these sky models. Because remember, with unguided imaging, it's just amount tracking, and the sky model and the encoders together have to do all that work. There isn't any sort of safety backstop with guiding. So in my experience with the 20-inch, I could, in certain parts of the sky, image 5 minutes, 10 minutes, unguided, and be able to pull it off. But I couldn't do it in every part of the sky on any conditions. And I found that implementing just a basic bump guiding type of approach where the guiding just every 10 seconds or so takes a 5-second exposure. It takes a look, and if it needs to give it a little bit of nudge, it does. So it's a very, very gentle form of guiding. The encoders are really doing the majority of the work. And the sky model, the sky model is changing in both axes the tracking rate in real time as it's moving through the sky. That to me is kind of like where I ended up going. And it was painful because we were so convinced that this was going to work. We didn't even send a guide scope. We didn't send an OAG. We didn't send anything. And it was a tough pill to swallow to have to send an OAG down there and a little guide scope. And of course, then they messed it up, and then suddenly our image train was off. So that, 3 months later, we eventually figured that out. But we really did not want to do that. And eventually we found that just recognizing what the limitations were going to be, primarily because the plane wave flexes, and it flexes in ways that is not entirely repeatable. Not bad, not saying anything bad about it. We love the telescope, but there is some variability that just can't be effectively modeled.
Okay, thank you. It's consistent with some of my experiences, especially the instability of Schmidt-Cassegrain systems versus, for example, RC scopes. So very good.
Yeah,
Thank you.
yeah.
hmm
My pleasure.
Well,
Oh, by the
Brian,
way, I just want to mention one more thing, by the way. Some of this variability can come from very odd places. So I work with a lot of people who have different kinds of things go wrong, and they want to know why unguided isn't working. We had a fellow whose filters in the filter wheel were loose and caused issues. We had a fellow who had, I think his OAG was slightly loose. So all of those things, you have to have like a really great performing system with everything tight as a baseline and then go from there.
Yes, for sure.
well, everybody, please join me in thanking Brian for this fascinating discussion and for sharing your time with us. We sincerely appreciate those of us who have encountered you in the professional side of your life know that there is no better support person that one could ever encounter. Truly, Brian.
My pleasure. My
harder to get things fixed for you. So thank you for joining us and for sharing so much interesting information. And Greg, back to you.
All right. Well, a couple of announcements. Our next month's meeting will be again on the third Monday. That's September the 15th. If you have images that you'd like to submit for the Desert Sky Bulletin, again, I remind you that I like to have those submitted to me and be less than 10 megabytes so they fit in the bulletin real nice. And last but not least, I don't know that the skies are going to cooperate tonight, but there's going to be a third passage of Titan shadow across Saturn starting about 11:30 Tucson time and lasting until about 4 o'clock in the morning. So if you're up and about during the wee hours and the skies cooperate, you might want to take a look at Saturn. All right. Well, again, Brian, thanks for your input, and we have a recording of this, so folks that didn't get to listen to it up front can look at the recording when I get it posted later this week.
Sounds good.
Okay.
Take care all. Thank you.
Thanks, everyone.
Thank you.
Thank you.